All right, moving on to number 22. Okay, number 22, we're solving the systems of inequalities by graphing. So let's graph these two puppies. They're both in y equals mx plus b form. That's easy. I'm going to plot my first y-intercept, which is at positive 1. We're going to go down 2 to the right 1. Okay, we're going to get our second point. We're going to go down 2 again to the right 1. Now it's less than or equal to. If it's an equal to function, we use a solid line. We know it's less than, so we go below the line and we shade down here. Graphing our second function, we have a y-intercept at negative 3, so go down 3 units on the y-axis. From there, our slope is positive 2 over 1. Positive 2 over 1. Now, this is not equal to, it's greater than, but not equal to, which means I have a dashed line. And I shade above that graph. So your solution set is whatever you shaded twice, which would be all of that right there. So any point in that solution set satisfies that system of inequalities. Moving on to number 24. Same thing, we're going to graph those two. So we got y is less than or equal to negative 4x plus 2, and y is greater than 4x plus 1. We're going to graph those two. So my first inequality has a y-intercept at positive 2, so go up 2. From there we're going to go, my slope is negative 4 over 1, so go down 4 over 1. I can connect those with a solid line because it is equal to, and it is less than, so I shade below the line. Going on to my next function, I have a y-intercept of positive 1. I have a slope of positive 4. I'm going to connect those with a dashed line, and I'm shading above that line. So my solution set is everything you shaded twice, which is this piece right here. All of that is your solution set. Going on to number 26, if I can find it. Oh. Okay, going on to number 28, because I don't see number 26 in here. Rock on. That's what I'm talking about. 26, everybody got it right. Alright, going on to number 28. Here we go. We're going to write our system of equations. We're going to have three variables here. So it says a food store makes an 11-pound mixture of pecans, pistachios, and dried bananas. Cost of pecans is $1.50 per pound. Pistachios cost $1 per pound, and dried bananas cost $1 per pound. The mixture calls for twice as many pecans as pistachios. Total cost of the mixture is $14. How much for each ingredient did the store use? Yeah. All right, so 28. Let's define our variables, right? So we're going to say that x is going to be equal to pecans. We have y, let's say that's equal to the pistachios. And then z can be equal to the dried bananas. All right, so now once we have our variables defined, we're going to write our equations. All right, so my first equation, it says a store makes an 11-pound mixture of all of those things. Store makes an 11-pound mixture of all of those things. So we've got x plus y plus z, pecans plus pistachios plus dried bananas equals 11-pound mixture. My second thing says the total cost of the mixture, the total cost of the mixture is $14. Now it says the mixture calls for twice as many pecans as pistachios. Twice as many pecans as pistachios. So the number of pecans, x, has to equal 2 times the number of pistachios. Okay, now my third equation needs to be equal to 14. We have 5x plus 1y plus 1z is equal to $14. Okay, 5x plus 1y plus 1z equals $14. So now we have our system of equations. Alright, you can solve this however you want to. You can solve by graphing, you can solve by substitution, you can solve by elimination. I don't care, you do you, boo-boo. Alright, so now we get X is the number of pecans, which we get 6 pounds of pecans. Y, which is the number of pistachios, we get 3. And then Z, we get 2. Alright, moving on to number 30. Number 30 says, what is the element A23 in the matrix A, right? So then this matrix, A sub 2, so second row, third column, -6. Going on to number 32, it says, how can you represent the system of equations with a matrix? So number 32, if we want to write this in matrix form, in augmented matrix form, what we're going to do is we're going to take our x's, -13, 5x, 7x, take our y's, which is -6, -5, +15, take our z's, which is 15, -13, +15, and augment that with our values, 5 and -12. Alright, going on to number 34, it says write the system as a matrix equation. What we're going to do is we're going to take our x's, write them in front. Now this one doesn't have an x, so we're going to put a 0 in place of x, -3 and 4. We're going to take our y's and write them next. This one has a 2 for a y, this one has a +1 for a y, this one does not have a y, so again a 0 as a placeholder. Take our z's, 4, this one does not have a z, and 6. And we're going to augment that with our -8, -2, -8. Moving on to number 36. Oh, no 36. Let's go on to number... Alright, number 38. Let me write it down. So number 38, we have our system is, let me walk around. We have 5x minus 5y equals 25. We have 5x plus y minus 4z equals -3. And we have -x plus 5z equals 4. Now I'm going to solve this by substitution. So the first thing I need to do is I need to get a variable by itself. If I look here, these are all divisible by 5. So I'm going to divide this first equation by 5. And I get x minus y equals 5. Now I can easily solve for x. All I need to do is move the y to the other side and I get x equals 5 plus y. I'm going to take that puppy and I'm going to substitute it into this second equation. So this thing is going in right here. So I've got 5 times x, which is 5 plus y minus 4z equals -3. Okay, I'm also going to take it, I'm going to substitute it into this equation. So I've got -x, 5 plus y, plus 5z equals 4. Right, so I'm doing substitution. I'm substituting it into both of these equations so I can get two equations with the same variables so then I can eliminate. Alright, so here I'm going to distribute. I've got 5 times 5, that's 25, plus 5y plus y minus 4z equals -3. Combine like terms, here they are. So we got 25, we're going to subtract that to the other side. So we get -28 over here. My like terms are 6y minus 4z. So my variables are y and z. If I look here, I'm going to have y and z. So I'm going to have two equations with the same variables. I can use the elimination method then to eliminate one of those. So let's distribute this. We've got -5 minus y plus 5z equals 4. So let's get this in this form. We need to add 5 to both sides. -y plus 5z equals 9. Now, I'm going to write this over here. So -y plus 5z equals 9. Now, in order to solve by elimination, I need the same number, different sign. So I need this to be a -6y. So I'm going to take this equation, I'm going to multiply it by 6. This is going to become -6y plus 30z equals 54. Now I can eliminate, right? 6y and -6y, those cancel out. This gives me a positive 26z. This gives me a positive 26. So I know that z is equal to 1. Fantastic. Let's take it, let's plug it back in, and let's find x. So if I look right here, I've got -x plus 5 times z. We know that z is now 1. That equals 4. So -x plus 5 equals 4. We're going to subtract 5 on both sides, and we know -x equals -1. So positive x has to equal positive 1. Now we know what x is, we know what z is. Let's find what y is. Doesn't matter what we plug into. I'm just going to take the top equation. So I've got 5 times x, 5 times 1, minus 5y equals 25. This is 5 minus 5y equals 25. Let's subtract 5 on both sides. So negative 5y equals positive 20. Divide by negative 5, y equals negative 4. So there are my 3 variables.